Now, we also talked about, just we will have little recap here. We also talked about axioms, assumption, you can say axiom assumptions, or you can say also properties that this technology that we are talking about satisfies, and I am going to talk about only few of them, there are more. So, one we said free disposal. What does it mean? That throwing away inputs is costless. You can dispose of inputs without spending any resources, fine. Or in other word, if certain amount of output can be produced by given amount of inputs, given amount of, you can say combination of inputs, then the same combination of inputs can also be used produce less amount of output. In other word, if I say that we talk about a production function when we have only one input and only one output, and we say that, for example, let us say that we need only milk to produce curd. So, if 1 kg of milk can be used to produce half kg of curd, then of course, 1 kg of milk can be used to produce only 250 grams of curd. So, here what we are saying, basically what we are talking about, the free disposal, that some of the inputs can be thrown out costlessly. Again think about it, why we are talking about it? Because we are talking about all the feasible combination of inputs and outputs, that is why I am describing it in particular fashion. So, if it is feasible to produce half kg of curd from 1 kg of milk, then it is feasible to produce 250 grams of curd from 1 kg of milk. So, the key word is feasibility. Technology represents the feasibilities, that the combination of inputs and outputs that can be achieved in this world given the current level of technology, fine. So, that is free disposal. The second is no free lunch, and this is quite famous term that we use in economics again and again, that no free lunch. And what does it mean here? But at least one input is required to produce some output, or more than one kind of output. So, at least one input has to be there. You cannot produce something out of thin air, you cannot conjure something. Like one example would be in the Harry Potter world. If you have watched Harry Potter movies, then Harry Potter cannot get nice feast just from the thin air. And if not Harry Potter, if you have read Chandrakanta book in Hindi, there also people would create something out of nothing, that is not possible in the real world. So, that is what we are talking about, no free lunch. Third is non-reversibility. What it means is that a production process cannot be reversed. So, if you obtain half kg of curd from 1 kg of milk, you cannot obtain 1 kg of milk from half kg of curd. In this example, it is quite clear, but you can say that let us say if 1 kg of steel is used to create 1 kg of nail, steel nail, then we can melt it and we can get 1 kg of steel, but the point there is that to get 1 kg of nail from 1 kg of steel, you have used certain amount of labor, certain amount of energy. You may get the steel back, but you would not get that energy consumed in the process, energy spent in the process, and labor hours spent in the process back. So, in that sense all the production processes are irreversible. And if you are familiar with the thermodynamics principle, if we have reversibility in the production process, then it would violate the laws of thermodynamics. Okay? In basically it is related to entropy. If you are not familiar with this term, forget about it, but you should just remember that a production process cannot be reversed. Okay? Fine. Okay. Next is convexity. Okay. But before we talk about convexity, we are going to talk about additivity that we talked about earlier and divisibility. Fine. What is additivity? Let us say that for example, 1 kg nail that we are talking about, it needs labor and nail, only two things, just keep it simple. Let us say that there are no other things required. So, let us say to get 1 kg of nail, we need 1 kg of, probably this is not very good example, let me change it. Let us say to write a software code, one software code, of course, we will have to define what do we mean by one software code, but let us say that there is such definition. It requires either 2 man hour, and this is also not a good example, let me think of something else. To produce 1 kg of rice, okay, you need either let us say 100 grams of fertilizer, let us say I am writing 100 grams of fertilizer as 1, okay, and 50 liters of water, that I am writing as 2. Let us say I can say 100 grams of fertilizer is 1 and 25 liter of water is 1. Okay. Fine. Same 1 kg of rice can be produced by 200 grams of using 200 grams of fertilizer. So, 2 and 25 liters of water. Of course, we need land, but that is fixed, those are fixed. So, we are not talking about it, only these two are variables. So,
shouldn't that be 2, like 1 kg of rice gives 1 and 2?
No, not give, this is 1 kg of rice is output,
and the thing that you written there at the top, 100 gram equals to 1 and 25 liters of water also equals to 1, shouldn't that be 2 there?
So, what I am saying here, let me write it in this term, this is 100 grams and this is 50 liter, and here it is 200 grams and 25 liter. So, that is what I am using 1 comma 2 and 2 comma 1. Fine. What additivity says that if these two are true, then 1 kg of rice can be produced using any linear combination of these two. Let us say, let me write, we have already learned how to write the linear combination of 2 points in this space. Where t is of course between 0 and 1. Why we are saying it? Let us take one approach here. Now, of course, we have figured out that 1 kg of rice can be produced from 1 comma 2 and 1 kg of rice can be produced 2 comma and 1, and we need to produce let us say 100 kgs of rice. What can we do? One way to do it is that we repeat this process 100 times. So, 100 multiplied by 1 comma 2, and another way is to repeat the second process 100 times. fine, we will get the 100 kgs of rice. Also what we can do, that we do the 50 times this process, the first process, and 50 times the second process. Fine, or any combination between 0 to 100 that we can take. We can say t times we take first process and 100 minus t times we take the second process. We will get the 100 kg, won't we? So, on average we are saying, this is what it is not always true, but I am saying on average what we can do is that we can produce 1 kg of rice here using t by 100 and 1 minus t by 100 2,1, and we can define this t as, we can say that instead of using t here, let us use t dash, this is t dash, this is t dash. So, now I can define that t dash by 100 is equal to t. So, 1 kg of rice can be produced by t 1, 2 plus 1 minus t 2,1, and this is what additivity is. If this is possible, then we say that technology exhibits additivity. Another related, but it may sound different, let us say if it is technologically feasible to produce, let us say y amount of output, and it is also technologically possible to produce y1 amount of output, then y plus y1 y dash amount of output is technologically feasible. I have made small mistake that I explained convexity rather than additivity. Chalo, ठीक है, ये we will, this is example of convexity. Okay, let us talk about additivity first. What is additivity? Let us say that a production plan is, let us talk in sense of first production set. If there is a production plan y, what does this production plan y means? That it gives certain combination of input and output that is feasible. Not just this y does not represent just amount of output. If you want to distinguish, you can say y hat to represent that this is a vector or this is a combination of input and output. And there is another production plan y dash. Okay. So, y bar and y bar dash both are feasible. Then what additivity says, that y bar plus y bar hat is also feasible. Is it clear? How we can explain it? If it is possible to produce, it is possible to have this production plan. Let us say, let us take an example, y bar is nothing but 1, 2, minus 1, minus 2, comma 1. What it means? That we are using 1 unit of input 1 and 2 units of input 2, and we are getting 1 unit of output. Now, y bar hat is, let us say 2, comma 1. Then what it means here is that here now we are using 2 units of input 1, 1 unit of input 2, and it leads to, it gives us 1 unit of output. Then this is also technologically possible that we use 3 units of both the inputs 1 and 2, and we get then 2 units of output. And what is the logic why we are saying it? Because if it is possible to produce 1 unit of output using this particular combination of input, and then again it is feasible to produce 1 unit of output by using this new combination, then of course we do these process once one by one, and we will get 2 units of output, and in the process we will use 3 units of both the inputs. So, again we are talking about feasibility, we are again talking about feasibility. Okay, fine. In other word, now let us come to divisibility. What is divisibility? if y bar is feasible production plan, if y bar is a feasible production plan, it means let us say this, take one example -1, -2 and 1. If this is a feasible production plan, then lambda y bar is also a feasible production plan. It means what we can do, where lambda is of course between 0 and 1. What it means is that we can use minus, let us say lambda is equal to half, then we can use minus half, we can use half unit of input 1, 1 unit of input 2 and then we get half unit of output. So, what we are saying is that a production process can be miniaturized, okay? A production process can be shrinked, fine. At this level it sounds very, it may not be possible sometime, but if we are talking about really large scale, then what we are saying that if we decrease all the inputs in the same proportion, then output will also decrease in the same proportion, and this is possible, this is feasible, fine, okay, it is clear. Okay. The easier way, although these two are not same, but the similar, one implies the other, but not the other way around. What we have is, we can say if input combination x, of course, if we are talking about input combination, then we do not need to put negative sign, it is automatically we can say all are negative because all are input. If this is the input combination and it is feasible to combine them in this way and get some output, then also it is also possible to combine lambda x 1 to lambda x 2. Of course, here we are not talking about the amount of output, but here we are not concerned about the amount of output. What we are concerned about it, whether it is feasible to combine the inputs in such a manner or not. Okay. When it is possible, then we say that technology exhibits divisibility, or production set or technology is divisible in nature, fine. Now, if we combine these two both, if both of these properties are satisfied, then we say that technology is convex. And what it means? So, let us look at it, what it means. We have taken example where 1 unit of output can be produced using 1 unit of input 1 and 2 unit of input 2. We have used a different symbols there. What we have used? -1, -2, -1, saying that these two are for inputs and this is for output. And similarly, what we have discussed, that this is also feasible. Then convexity says that here, let us say this is y bar and this is y bar dash. Then, or in other word, if it is possible, then y bar is an element in the production set. I am just rewriting it, and production set we denote it by capital Y, fine. Sorry, this should be here. These both are feasible production plan, that is what I am saying, that y bar and y bar dash are feasible production plan. So, then what it means further, if it exhibits convexity, then T y bar and 1 minus T y bar dash is also feasible. And how we can do it? What is the logic? We can say, let us say we take that 1 unit of output can be produced using 1 unit of input 1 and 2 units of input 2, and next the production process says that same 1 unit of output can be produced using 2 units of input 1 and 1 unit of input 2. Now, let us say we just do not want to produce 1 unit, we want to produce 100 units. So, 100 units we can produce by replicating this process 100 times. So, what we can do? By using 100 units of input 1 and 200 units of input 2. and we will get 1 unit of output, 100 units of output. Similarly, we can repeat this process 100 times, and in that case we will use 200 units of input 1 and 100 units of input 2, and what we will get? Both will give us 100 units of output. The other way we can do it, that we can combine it, let us say 50 times process 1 and 50 times process 2, and what we will have? That we will get 50 units of output using 50 units of input 1 and 100 units of input 2, and again 50 times we will use the second process, and here we will use up 100 units of input 1 and 50 units of input 2. If we add these two up, we will get 100 units of output, okay? And what we are using? Basically 150 units of both the input. So, instead of doing it for each number, what we can do, that we can take this process, let us say t naught time, and this process 100 minus t naught times. What we will get? We will get 100 units of output, and what is happening there? We can say 100 units of output we can obtain using t naught 1 comma 2 plus 100 minus t naught 2 comma 1, and this is where additivity kicks in. We are able to add these two up. Now, we will use the divisibility property. We will say that on average, if we are using 100 times like this, so on average we want to produce 1 kg and divisibility is allowed, then what will happen? If we divide it by 100, what we get? T naught by 100 1 comma 2 and 1 minus T naught by 100 2 comma 1, and this will give us 1 kg or 1 unit of output. And if we define this T naught by 100 using, say that T naught by 100 rather than using 100, we say it is T. So, basically T 1 comma 2 1 minus T 2 comma 1 will give us again 1 unit of output. So, what we are saying basically that, okay, we start with y bar and y bar dash, then if these two are feasible, then T y bar plus T y bar dash is also feasible. Here y is taking care of not only inputs, but also output. The combination is all given here, and this exhibits convexity. Is it clear?